Hey you guys, I'm going to be going through a gas law problem that I think many of you were struggling with when we were doing that gas law problem lesson. And so look at the text of the forum and see what the numbers are and what this question is exactly asking. But what we're given in this particular problem is that we have a 300 milliliter sample of gas that's initially at a 460 torr pressure and a temperature of 20 degrees Celsius. It's then compressed into a smaller volume of 260 milliliters, and the pressure increases to 500 torr. And we're asked to solve for the temperature here, the new temperature. Now the first step I always do in these problems is I always write out exactly what I'm given. Because most of the time, when you write out exactly what you're given here with V1s and P1s and T1s and whatnot, you can really quickly look and see which equation you need to be using. And there's a table in your book, I think it's table 11.4, that you should have by your side while you're taking your final exam. I don't expect you to have all of these equations memorized. I just expect you to know how to use them and know when to use the right one. So in this case, we would look at that table and we would see which equation has all three of these. And I know I'm telling you to use that table, and I don't actually think the equation we're going to be using is in there. But in the text of the book, you can find we're going to be using the combined gas law here because it's the one that has all three of these. And the combined gas law is P1 V1 over T1 equals P2 V2 over T2. So there's a lot of, we have P1s, V1s, T1s, P2, V2, and we're trying to solve for T2. So the very first step in all of these gas problems is you must convert your temperature to Kelvin. So in this case, we're going to convert this 20 degrees C plus 273 is 293 Kelvin. If you don't have your temperatures in kelvins, you are going to get the wrong answer, and I will take points off for it. So convert, because I've said this multiple times, convert temperatures to Kelvin. So the next thing we're going to do is we are going to rearrange this equation here to solve for T2, because that's what we want to solve for. So what I recommend that you do in these kind of equations when you're doing the algebra is you multiply across and set them equal to each other. So in this case, we're going to have T1 P2 V2 equals T2 P1 V1. Okay, so we multiplied across in the ratios and set them equal to each other. We then divide through to isolate T2. So I'm going to switch these around here too. We have T2 is equal to T1 P2 V2 over P1 V1. So this is going to be the equation that we are going to be using to solve the rest of this problem. And this is exactly, this one I picked because it was a little bit more complicated algebra and a little bit more of a complicated equation, but this is the exact same process that you do for any of these problems. So now we can just plug and chug, just plug in all the numbers that we're given. So we have T2 is equal to 293 Kelvin times 500 torr. Oop, I'm getting a little bit crowded there. Times 260 milliliters all over 460 torr and 300 milliliters. In this case, I'm going to show you how the units cancel so that you believe me that we didn't have to convert milliliters to liters and we didn't have to convert torr to atmospheres or anything in this particular problem. The torrs cancel out on the top and bottom, the milliliters cancel out on the top and bottom, and we're left with Kelvin, which is, since we're solving for a temperature, that's exactly what we want. So if you work all this through on your calculator, multiply and then divide, you get that T2 is equal to 276 Kelvin. Most of these problems are going to ask for your answers in degrees Celsius, so you'll need to subtract 273 from that. So we get T2 is equal to 3.01. This is at the, I just kept all this in my calculator, which is why there's a decimal place there, but this is really 3 degrees Celsius. Okay? So that's how you work your way through one of these problems. You work it all the way through and you solve for temperature 2. These gas law problems are going to be really important to know for your final exam, how to use all those different equations. Like I say, don't memorize them, just have them close by and know how to use them, especially that one that's PV equals nRT. That's a really, really important one as well too. And of course, just let me know if you guys have any other questions. Thanks for watching, guys.